All right, so on this one, we're wanting to factor, and they give us a nice helpful hint out here. Factor out the GCF first. Honestly, I'm not going to put those on the exam. You're going to have to be aware of that, be thinking about that. So it's nice for homework because we're just getting used to things, but by the time we get to the exam, you're going to have to know that. So that's always the first step on every factoring problem. Is there anything in common? So you look at the 18, 20, what goes into 18, 21, and 6? Well, they're all divisible by 3. Okay. So divide them all by 3, that'll leave 6, that'll leave 7, and that'll leave 2. They're all divisible by 3. So the answer is yes, 3, but not just 3. Careful now. Careful. We've got to get everything. If we get just part of it, we'll mess up the problem. We've got to get everything they have in common. So what else do they have in common in addition to the 3? Well, they all have the letter Y, don't they? See that? Y, Y, Y. So it's 3Y. So it's 3 and Y. So what do you do about that? You put the 3Y in the front and the one big old parenthesis with the 3 terms on the inside with the minus and the plus, and then you figure out what goes on the inside so that it'll go back. Right? You put the GCF, it's called, in the front, the greatest common factor, the greatest amount they have in common in the front. So I'll do that. So I'm going to put 3Y in the front, and then one big old parenthesis, 3 terms on the inside with the minus and the plus, and then whatever works. 3Y times what? Well, it's going to be 6. And then what does it need letter-wise? X squared, huh? 3Y times 6x squared makes 18 x squared y, doesn't it? And then 3y times what? Well, it's going to be 7. And what does it need letter-wise? X, right? 3y times 7x is 3 times 7, 21 xy. And then 3 times what? 2. What does it need letter-wise? Doesn't need anything because 3y times 2 is 6y. It's already got the y. We good there? So make sure, the big lesson there is make sure when you do a GCF that you get everything they have in common, not just the 3. It's an easy mistake to make to only take out the 3 and forget that they also have a y in common. You got to get all the numbers and all the letters that they have in common out. Okay, that's the first step. Now for the second step, step 2. Step 2, we're going to leave the 3y in the front, and we're going to factor the inside 3 terms. And how do we factor the inside 3 terms into 2 parentheses? And how do we do that? You know, it's multiply, add, multiply. That's how we always factor 3 terms, is multiply, add, multiply. Okay. And you're going to leave the 3y in the front. So 3y is going to stay in the front. And then I'm going to have like 2 parentheses. And now we're going to do the possibilities. What are the possibilities? Well, what multiplies to be 6? Let's start. What multiplies to equal 6? Well, now remember what you want to do is you want to start with the numbers that are close together. I'm going to go 2 times 3 and then 1 times 6. There's 2 possibilities, aren't there? So we always do first you start with the numbers closest together. That's the first rule. Start with numbers closer together, like 2 and 3. And then what about the multiply at the back with the 2? What multiplies to equal 2? Well, there's only one option. 1 times 2, that's nice. There's only one option there. So my point is I'm going to first start. In fact, I want to make this note a little bigger here. So first start with the numbers closer together. Oops. So first start or first try the numbers. Well, I don't have room for that right there. I just realized. So this one's first because the numbers are closer together. start with 2 times 3 because the numbers are closer, right? Whereas 1 and 6 are further apart. So always start with the numbers closer together. Okay. So then I go back here and I go, okay. So I'm going to say 2x, 3x. And it doesn't matter what, if that bugs you, you can say, well, I'll put the 3 first, whatever. The order on the first two doesn't matter, but once they're down, then the order in the back two will. So on the back two, I'm going to go 1 times 2. So I could go 1 times 2, and then we can switch it up, right? Then we can say, okay, how about the other order? What about put a line here? And we say there's another order, and now I'm going to again put the 3y. Oops, move there. We can put the 3y's in the front, the 2 parentheses, and again the 3x and 2x in the front. But then we can switch the order on the back two. We can put the 2 here and the 1 there, right? Because you got to switch up the order, right? I'll say that this is or, right? It could be either one of those. And really, those could both not work. And then we need to try the 1-6 combo. It could be. It probably is not. It's usually the numbers closer together. Probably it's the 2-3 combo that's going to work. But let's first try the 2-3. If it doesn't work, we'll go to the 1-6. Okay, so you're good so far. So when you're factoring the multiply, add, multiply, you got to write down what multiplies to be the first one. What multiplies to be 6, 2 and 3, or 1 and 6. Start with the 2 and 3 because those are closer together. And then what multiplies to be the 2 in the back, there's only one option, 1 times 2. So I put 3 and 2 in the front with 1 and 2 in the back, and then I switch the order, 2 and 1 in the back. You got to try the other order because that makes a difference. Okay, now a second shortcut rule. Let me help you with another shortcut rule here. Never two numbers in the same parenthesis that have anything in common. You're never, like, for example, you're never going to have 2x and 4. You're never going to have 3x and 6 because, right, these are both divisible by 2. These are both divisible by 3. No, you're never going to have that. Why not? Because we got all the commonness out on the first step, right? That was the first step. So the final answer cannot have anything in common in the parentheses. So what does that mean then? That means no right there. I'm not even going to try that. I'm not going to waste my time to try that one. That one is a for sure, forget it, because of this right here. Right? Do you see that? You cannot have two 2's in the same parenthesis. They both are divisible by 2. So that can't be it. So I'm not even going to bother to try that one because trying takes some time. I don't want to waste that time. But so I'm going to check this other one because this other one's good. This other one has a possibility of working. 3 and 2 have nothing in common. 2 and 1 have nothing in common. It might be right. Let's try it. So you know how to check, right? First to both, second to both. 6x squared, 3x. Right? That 3x went to both those. 6x squared and 3x. And now the 2 is going to go to both. 4x and 2. Let's space that out a little bit more. 4x and 2. All right. So is it right? How do we know? Well, now it's all about the middle. They have to add. These 2 in the middle have to add to be the middle. How can 3x and 4x make negative 7x? Both negative. These add to be negative 7x, don't they? Right? Think about money. If you lose $3 and you lose $4, you lost $7. So that's working. That's a big check. Yeah. So then they're both negative. Put them up here, both negative. Double check the back. Is negative 2 times negative 1 in the back? What is that? Positive. Yeah, 2 negatives multiply to be positive 2. Check. That's what we want. Positive 2. Beautiful. That's it. That's our answer. You see how the check is working perfectly? Right? The 2 in the middle, minus 3x and minus 4x makes minus 7x, which is what it's supposed to make. And then so you put negatives on both these guys. And then negative times negative makes positive 2. That's perfect. That's it. So that's our answer. We can bring it on up now, right up here. This is the answer. So don't forget about the 3y in the front, the greatest common factor we took out on step 1. 3x minus 2, 2x minus 1. There it is. And again, you could switch order. You could have the 2x minus 1 and you could switch the order on these guys. I mean, the whole parenthesis. This whole parenthesis could go on the back. It doesn't matter. And there it is.